Okay, let's look at Pythagorean theorem more as a formula than as a geometric representation. So in these problems, I first want to identify what it is I'm solving for. Is it a leg or a hypotenuse? So again, I need to know where that right angle is, and that right angle points to the hypotenuse. So in this problem, I am solving for the hypotenuse. So I'm going to use my formula of leg squared plus the other leg squared is going to equal the hypotenuse squared. So in this case, since my two legs are both 12, I'm going to have 12 squared plus 12 squared equals h squared. Remember, I still have to square the variable that I'm solving for. I'm going to go through and do my math. And I get to this point here where I have 288 equals h squared. And from here, I do not know, this one's not on my perfect square list, and you're looking at it and thinking, do I divide by 2? What do I do? Now remember, with the h squared, I need what number times itself gives me that 288. I don't know what that is. Sorry, I want to do it with the pen. I don't know what that's going to be, so I want to go through and I'm going to square root both sides. The square root and the squared is what undoes each other. So I'm left with the h here, and I go to my calculator. Again, if you don't know where that button is on your calculator, please check in with me. And I get that the h, rounding to the hundredths, is 16.97. Again, it should be that longest side because of the hypotenuse, and 16.97 is greater than 12. Okay, let's look at the next example. Again, with the next example here to the right, I'm identifying that I am again solving for the hypotenuse here because it's across from that right angle. So when I go through and start plugging in my numbers here, I'm taking one of the legs, so 7.5 squared, plus 3 squared, and I'm going to set that up so it equals hypotenuse squared. And now I'm going to go through and go to my calculator to basically work out my left-hand side there. Again, I get to this point where I have h squared equals 65.25. So again, I'm going to square root both sides. And if I just stop and think about it, what number times itself gives me about 65, I should be able to realize that that's going to be a little bit bigger than 8. And so when I go to my calculator and type it in, I get back rounding to the hundredths 8.08, which again makes sense because it is the longest side out of that right triangle. Let's look at some examples where I'm actually going to be solving for a leg. In these examples, I know I'm solving for a leg because, again, there's my right angle and it's pointing to my hypotenuse, which is 13.5. So I know my answer for x is going to be smaller than 13.5 by the time I'm done. So if I go through and I think about this, I do not know what that first leg is. So I'm just going to call it, and I'm going to square it, plus that 9.7 squared. And now I also take my hypotenuse, which is 13.5, and I'm squaring that. And I'm going to go to my calculator and fill in the numbers after I square them. From here, it's just a balance problem once you fill those numbers in. So take a moment then, and then go through and subtract from both sides that, in this case, 94.09. And we have this x squared equals 88.16. Again, I'm just going to my calculator. From there, again, we're still going to square root to get that answer. And again, just by thinking about it, I know it's going to be somewhere between 9 and 10 because my perfect squares are 81 and 100. And so when I am done square rooting both sides here, I'm getting then an answer of x equals 9.39 when I'm done rounding to the hundredths, because again, that's an irrational number. That makes sense because 13.5 has to be my biggest side, and so 9.39 is smaller than that. Okay, let's look at one more there to the right, and it's the same idea. I have 6 being my hypotenuse because it is across from that right angle. So again, I do not know what my leg is there. So I'm going to call that x squared. And then I'm going to have 3 squared equals then 6 squared. And again, go to my calculator for my numbers and then go through and realize, oh, this is really just a balancing problem. So I'm going to subtract 9 from both sides there, and I get x squared equals that 27. Now again, not knowing what the perfect square, it's not a perfect square, right? But it's going to be something a little bit bigger than 5. So I'm going to get that x is 5.20 when I'm done rounding. And again, that makes sense because my hypotenuse is 6 and that should be my biggest side. Let's look down to this last part. The last neat thing about Pythagorean theorem says that if the formula works, then the triangle must be a right triangle. So if I have a triangle as pictured here, and I have the 3 lengths, I can figure out if these guys are right triangles by just testing them in Pythagorean theorem. Again, I have to look to see which side is my longest side and assume that's my hypotenuse. So I'm just writing h's next to those. So basically I want to go through and see if these numbers work in Pythagorean's theorem. So it'll look like this. Once I have my formula all written out here, I'm just going to go through and plug it into my calculator and see if the equations work. And checking them in my calculator, I can see that this first one goes through and I end up with 9 equals 11.56, which is not true. So this guy is not a right triangle. That means this guy is not a right triangle in here. And then, but 36 does equal 36. So that means, yes, this is a right triangle and that must have been a right angle there.